Okay, so the next thing that we have here is called events or event basically. And so let's see what an event is. We have studied about random experiment and sample space associated with an experiment. The sample space serves as a universal set for all questions concerned with the experiment. So we talked about the random experiment, and just as a review, a random experiment we said that basically an experiment is called a random experiment. It's called a random experiment if if the following two conditions are met in the case of the experiment. Number one, if there is more than one outcome, and if there is no way to know which outcome occurs. So that's called a random experiment. The sample space of a random experiment is basically, we already had a so the set of outcomes, we said that the set of outcomes of an experiment, of a random experiment, is called the sample space, the sample space of the experiment. And what is an outcome? So a possible result of a random experiment is called its outcome. So the outcome, we said that as outcome basically is a possible result of a random experiment. A possible result of a random experiment. Okay, so that is that. Now, let's go back over here. So So in the case of the event, we said that we have studied about random experiments and sample space associated with an experiment. The sample space serves as an universal set for all questions concerned with the experiment. Now consider the experiment of tossing a coin 2 times. So consider the experiment of tossing a coin 2 times. An associated sample space is basically S is equal to heads, and then heads, heads, and then tails, tails, and then heads, tails, and then tails. So consider the experiment of tossing a coin 2 times. This is the experiment of tossing a coin 2 times. Right? Now suppose that we are interested in those outcomes which correspond to the occurrence of exactly one head. To the occurrence of exactly one head, which would be basically, for example, these two here. We find that HT and TH are the only elements of S corresponding to the occurrence of this happening or event. These two elements from these two elements form the set E, which is equal to, for example, based on that condition, we can say that, for example, some set E is equal to HT and, for example, TH. We know that the set E is a subset of the sample set S. So this set, of course, is a subset of this set. Similarly, we find that the following correspondence between events and subsets of S. And so for example, you have description of an event and corresponding subset of S. So for example, the number of tails is exactly 2, meaning that, for example, that you could have, for example, you could define any sort of event really. So if for example, if you say that the number of tails is exactly 2, the number of tails is exactly 2, then, for example, that corresponds to this subset, for example, A, which would be equal to, for example, TT. Or if you say that, for example, the number of tails is at least 1, the number of tails is at least 1. At least 1 would be this one, and this one. So there would be a subset, for example, B, which would be, for example, HT, TH, TT. And you could say that, for example, the number of heads is at most 1. The number of heads at most 1. The number of heads at most 1 would be, for example, these two members here. So you could have, for example, some subset C with, for example, heads at most 1. So HT and TH. Or you could say that, for example, that the number of, or the second toss is not head. Second toss, not head. Second toss, not head would be, for example, some subset D with, for example, HT and TT. HT and TT. Or you could say that the number of tails is at most 2. The number of tails at most 2, which would be, for example, some subset like call it, for example, S, and the number of tails at most 2. So which would be basically all of these members, really, because you are, I mean, your condition does include all of these members, so you would get the same set S basically. So HH, for example, HT and TH and for example TT, right? Or you could say that the number of tails is more than 2, or the number of tails more than 2, which would be basically the null set, because there is no such member here. So the above discussion suggests that a subset of sample space is associated with an event, and an event is associated with a subset of sample space. So I read this question, this part again. It says that the above discussion suggests that a subset of sample space, so these are all subsets of the sample space, a subset of sample space, that a subset of sample space is associated with an event. For example, these are the events that we are talking about. These are all basically events that we are talking about. So you can see that any subset is associated with an event, and an event is associated with a subset of the sample space. In the light of this, we define an event as follows. So, as a definition, I like definitions, really. If you can define something, then that means that you know what you're talking about. If you cannot define something, that means that you're talking about something that you don't understand, which you shouldn't talk about. So that's basically why I like the definition so much. Any subset E of a sample space S is called an event. So they have defined, which is of course not a very good definition probably, any subset E of a sample space S is called an event. So basically, up to now, basically we called this an event and this a subset, and these two we said that we were associated. But it seems that they have kind of defined both of them as just one thing, which is okay. There is necessarily no problem with that. So the next thing that we have here is occurrence of an event. The next thing that we have here is called the occurrence of an event. Okay, so about the occurrence of an event, it says that consider the experiment of throwing a dice. Let E denote the event. A number less than 4 appears. If actually 1 had appeared on the dice, then we would say that, if I were to rephrase, if actually 1 appeared on the dice, then we would say that the event E has occurred. As a matter of fact, if outcomes are 2, 3, we say that event E has occurred. So So the sentences are not very clear here, so let me rephrase them. So for example, consider the experiment of throwing a dice. So when you throw a dice, the possible outcomes of this experiment are 1, 2, 3, 4, 5, and 6. You can call this the sample space of the experiment. Now, suppose that you define an event E, which is a number less than 4 appears. A number less than 4 appears on the dice. That means that basically if any number like 1, 2, or 3 appears on the dice, if I call this subset, for example, A, if any number basically like 1, 2, or 3 appears on the dice, that means that event E has happened. So, thus the event E of a sample space S is said to have occurred if the outcome omega of the experiment is such that omega is a subset of E. So the event, I got confused here because I have written things here not the way that they are written over there. So then basically if the event E is a number less than 4 appears on the dice, then if one occurs, then we say that event E has occurred. If 2 appears on the dice, we say that basically event E has occurred. If 3 appears on the dice, we say that event E has occurred. So the event E of a sample space S, so thus the event E of a sample space S is said to have occurred if the outcome omega of the experiment omega of the experiment is a subset, is such that omega is a subset of, or omega belongs to the set E, or belongs to, of course E would be an event, so based on the definition that we had before, you can think of basically the event E as a set as well. So then you can say that basically in this case, for example, set E would be basically 1, 2, and 3. And so if omega, which is basically this outcome, any of these outcomes here, if omega is, you can say that if omega happens or occurs, you can say that basically the event E has occurred. That's how I understand it. So again, thus the event E of a sample space, meaning that this event, this you can call an event, and the way that I understand it, based on the definition that we had, you could call this the event E, and you could also call this the event E, because they are